Good afternoon, this is seraph.millar. This is the immune system flow chart discussion video. Okay, so anyway, we have an immune system. Let's switch you around. So basically, there we go. We have our immune system, and that immune system breaks into innate immunity and adaptive immunity. When we have our innate immunity, that breaks down into bloodborne pathogens that turn into phagocytes, and they can be neutrophils, macrophages, basophils, eosinophils, and natural killer cells. All of those phagocytes create death of the pathogen. Now, in our innate immunity also, we have physical barriers. That would be our skin, the mucous membrane, saliva, our urine, tears that we can flush the antigens out of our eyes, and also our stomach acid. And these are all ways to stop the infection from happening. So in the adaptive immunity, we also, from our adaptive immunity, we go into either T cells or B cells. So our T cells get broken down into suppressor cells, helper cells, and cytotoxic cells. All three of these cause death of body cells that are infected with the pathogen. When we have our B cells, the B cells turn into lymphoblasts, but they go through an antigen exposure. So the B cells are exposed or come into contact with the antigen, and that creates the lymphoblast. That lymphoblast turns into either a plasma cell, which is going to be our antibody, or a memory cell, which is storing the antigen information for a later date for when we are exposed to it. So this is a little bit more descriptive breakdown. So as our pathogen enters the body, the macrophage detects it and engulfs it. That macrophage presents the antigen and calls for help with cytokines. Those cytokines go out into the body and attract the natural killer cells, who are then activated. This helps to identify the invader. These cytokines also help the basophils and mast cells release heparin and histamine. This decreases the blood viscosity, increases blood flow, which increases our leukocytes to the area and inflammation. On top of the cytokines, the APCs show antigens. This is also a macrophage. The antigens are either going to be MHC1 or MHC2, and then they travel to the lymph nodes with these. This top half here is our innate response. This is where our physical barriers happen and our bloodborne barriers happen. So now we're going to go into the adaptive response. So once they've traveled to the lymph nodes, they are either met with hyper T cells that bind to the antigen, and these proliferate and they create memory effector T cells and regulator cells, and these coordinate an immune response with B cells and macrophages simultaneously. From that, this is when our B cells are then brought in. So our naive B cells are activated by the Th cells. They activate B cells' clonal expansion and somatic hypermutation, also known as centroblasts. The centroblast becomes a centrocytes, and these present the antigens to the T cells. So once they are presented, they either come a plasma cell or a memory cell. The plasma cell is our antibodies, and those antibodies use the virus that they identify and engulf it through through a phagocyte. So also from our lymph node, we have the T cells combined with the antigen and the dendrite cell, which is activation and proliferation of the T cells. The T cells leave the lymphocyte and go to the infection. They ID the infection in and on healthy cells, and they identify the healthy cells. They destroy only the infected cells. So this is where our body can tell which cells have the disease and which ones don't, and it only kills the cells with disease in it. And they do this through engulfing the pathogen.